Hello and welcome. Today we are going to solve our fourth problem of Leetcode, that is median of two sorted array. So in this problem we have given two sorted array, that is nums1 and nums2 of size m and n, and we have to return the median of two sorted array. So we can see that in the first test case we have a array of nums1, that is 1 3, and nums2 2. After merging this we will get a resultant array of 1 2 3, and after finding the median of this array we will find out it is going to be equal to 2. For the second test case we have given to array of 1 2 and 3 4. After merging this we will get a resultant array of 1 2 3 4, and whenever we will try to find out the median, it is going to be equal to sum of two middle element divided by 2, as it is a length of even numbers. Okay, so it is going to be equal to 2.5. So these two are small test cases, and for this problem it is not going to be enough. So I have already written down a test case in whiteboard. Let's understand this. So we can see that we have written a test case. So in nums1 it is sorted and the elements are 2 4 5 6 9. In nums2 it is also sorted, 1 3 7 8 10 are its element. After merging this we will find a resultant array which is 1 2 3 4 5 6 7 8 9 10. Okay, so if you have to find out the median, then as we all know that for even length array the median is going to be equal to two middle element, sum of two middle element divided by 2. It is going to be equal to 5 plus 6, 1 second, yeah, 5 plus 6 divided by 2, that is equal to 5.5. Okay, but what if we have odd length array? In that case we have to return the middle element, that is going to equal to 6. So in this case it is going to be equal to 6. Okay, so we have understand what is median and how we can find out for even and odd length. So okay, so how we can solve this problem? The very naive solution is going to be to store all element in an array. So for that we have to create a nums array, let's say, of size n plus m, and in this array we have to store all the element 2 4 5 6 9 1 3 7 8 10. After that we have to sort this. After sorting we will get resultant as this array, and then we can easily find out the median. But the problem is that it is going to be very time consuming, and we don't want our solution that much time consuming, so it is not the recommended one. And if we look at the test this approach, and the time complexity is going to be equal to big O of n for storing all the element plus big O of log n for sorting the array. Then after we have to find the result, so it is very much time consuming, and also this is going to take big O of n, a space complexity, and this is the time complexity. So this is not the recommended one. So how we can optimize this? Okay, we can use a two pointer method for further optimization. How we can use that? Let's see. So we have already, again we are storing all the element in an array but using two pointer method. How we can do that? So first write down 2 4 5 6 9 1 3 7 8 9. So we have placed one pointer at first array and second pointer at second array. We'll compare both the pointers. Here we can see that 1 is lesser than 2. I'll insert 1 in array and move the pointer to next ahead. Okay, compare 2 and 3. 2 is lesser, store here and move the pointer. 3 and 4 will be compared. 3 is smaller, 3 will be here and move the pointer. 4 and 7 will be compared. 4 is smaller, 4 is placed here and move the pointer. 5 and 7 will be compared. 5 is smaller, 5 will placed here and move the pointer. 6 and 7 will be compared. 6 will be stored and move the pointer. Sorry, it is 10. So then we'll compare 7 and 9. 7 will be stored, pointer will move ahead. 9 and 10, sorry, 8 and 9, 8 will be smaller, 8 will be stored, then move the pointer. 9 and 10 will be compared, 9 will be stored, then move the pointer. Now it is ended the first array, so we can store all the remaining element of array 2. So here we can see that we have found out resultant array, and then we can return result of this two element. Okay, after After this we can easily return the our median. But again here the space complexity is same as the previous one. So can you do something here? Yeah. So it is going to be equal to big O of, sorry, yeah, it is going to equal to big O of n. The space complexity is going to be equal to big O of n. Can you optimize this? Let's see how we can. So rather than storing this array, we can simply check if it is of even length. We can simply check the two million middle element, which is going to be equal to fifth and sixth element, which is, so we will keep a counter, and whenever we will compare and move the pointer, we will also move our counter to +1. And whenever counter will be equal to middle element 5 and 6, we will store those middle element and we can simply return the median after that. Okay, so again this is taking the time complexity of big O of n and space complexity of big O of 1. This is better than two previous solution, but still it is not optimized one. The how we can optimize this? So for that, let's see how we can. So we can see that the given array is in sorted form. So whenever we have any array in sorted form, the first thing that we can think of is binary search. Yeah, but how binary search can solve this problem? For that, let's understand this using next slide. Yeah, so I have already written down something here. So let's see what it is. So here we are going to make partitions in two arrays. So let's say if we are considering all the element of array 2, and then we have to consider 0 element from array 1, as we can consider maximum of 5 from one array. So we have made partition for this. So how can made partition? So these are some partition that I already made that are valid one, and among these we have to find the right partition that going to apply in this solution. Okay, so in the first partition I have taken 0 element at left side and all the element of in right side from first array, and all the element for in left side and 0 element for the right side for second array. So it is going to be something like 2, sorry, in left side it is going to 1 3 7 8 10, and in right side it is going to equal to 2 4 5 6 9. Okay, so this is the L1. Here L1 will be negative index, it can be minus infinity, and R2 similarly can be plus infinity. Okay, so we can see that in left side there are many elements which are greater than right side element, so this is not the valid one. Again, for looking second test case, so here we can see that I have taken one element for from array 1 and four element for from array 2. So L1 will be 2, L2 will be 8, similarly R1 and R2 will be 4 and 10. And looking at this, there are many elements like 8 which is greater than elements from right sides. So we can see that 4 is lesser than 8, it is not the valid one. If we are partitioning in that case, all the elements that are in left side should be lesser than all the elements that are in right side. So this is not the valid one again. So let's move forward. In this case again we can see that 7 is greater than 5, so again this is not the valid one. So let's see this test. Let's see this partition. In this case that are all the element are which are in left side is lesser than element that are in right side. So we can see 1 2 3 4 5, these are going to be in 1 2 3 4 5 in left side array, and 6 7 8 9 10 is going to be at right side. So in this case we can easily find out which is going to be two middle element for our median. So we can see that the first middle element is going to be among L1 and L2, and the second middle element is going to among R1 and R2. So this one is the valid one partition. So let's clean up this. Okay, so how we can use binary search for this? So I have already written a dummy for a binary search. So whenever you try to find the binary search, we first find out the middle element by using left plus right by 2, and there will be some cases which is going to be true. In that case, we have to return some value or do some calculation. And for some cases, we have to move either left or right. So in if this condition is true, then we have to move left and right. So we'll try to find out all the cases. So I have already find out the partition one. Partition one will be find out from left plus right by 2. So how we can find out the partition 2? For finding the partition 2, as we know that minimum of m plus n by 2 element should be on left side and n plus n by 2 element should be on right side in the case of even array. But what if you have odd array? So let's say we have array of size 11. Okay, so in this case either we can keep 5 element at left side and 6 element at right side, or similarly 6 element at left side and 5 element at left side. So we can do this by using m plus n plus 1 by 2. Okay, so if we'll check, then we'll find out there's 5 if the first array is length 5 and second is 6 by 2, it is going to be equal to 11 by 2. In 5 plus 5 plus 1, it is going to be equal to 11 by 2. Again it is going to be equal to 5. So this is true for even length, and for odd length it is going to be equal to, let's say, 5 plus 6 plus 1 by 2, it is going to be equal to 6. So it is also true for odd lengths. I am considering the second test. Okay, so we have figured out how we can find out the partition 2. Let's find out, write down the partition 2 here. So partition 2 is going to be equal to m plus n plus 1 by 2 minus partition 1. Okay, so we have found out our partition 1 and partition 2. Now coming backward, here we can see that we have to find out L1, R1, L2, R2. What is L1, L2? L1, L2 are the extreme position of left side array that we are considering. Like here L1 is the third element and L2 is this element. So these two are L1, L2, and similarly R1 is the first element of right side array from both the arrays. So R1 and R2. So how we can find out L1 and L2? Here we can see that L1 can be find out. So whenever you make any partition, let's say this is the partition. So L1 is going to be equal to nums 1 and partition 1 minus 1. We can confirm from this, yeah. And L2 is going to equal to similarly nums 2 and partition 2 minus 1 for this. Okay, so we have find out L1 and L2. Similarly R1, R2 we have to find out. It is going to be equal to nums 1 index forward, that is one index next to the L1. So it is going to equal to partition 1 and nums 2 partition 2. Okay, so this is the ideal case when all the elements are in middle. But what if we are in extreme position, like for this case? In this case 11 is going to be minus infinity. So how you can find out this case? Whenever our partition value is going to be equal to 0. Okay, so in this case it will be minus infinity. Similarly for this it is going to be minus infinity, and for the extreme case, this for this condition it is going to be R1 is going to be plus infinity and L2 is going to be plus infinity. So L2 is going to be minus infinity, and in this case it's going to be plus infinity. So yeah, so R1 is going to be plus infinity in extreme cases whenever our partition is going to be equal to n or m for the second array, n for first array and m for second array. So plus infinity in this case. Okay, so we have found out our L1 and L2. Let's write down this. So L1 is going to be equal to, first we have to check out whether partition 1 equals to 0. If it is true, then minus infinity, otherwise nums 1 partition 1 minus 1. Okay, and similarly L2 is going to be equal to, we have to first check out the partition 2 is equal to 0. If it is true, it is going to equal to minus infinity, otherwise nums 2 partition 2 minus 1. R1 will be similarly, we have to check out partition 1 is equal to n. If it is true, then we have to put it at plus infinity, and if it is not true, then in that case we can put it as nums 1 and partition 1. Similarly for R2, partition 2 will be checked. If it is true to m, then it is going to be plus infinity, or num2 it's going to be equal to nums2 partition 2. So we have find out our L1, L2 and R1, R2. Okay, we have find out it, and we have to check these three conditions here. The remaining things are here. Okay, we have to check this condition, this condition, this condition. So what are these conditions? Let's see. So let's clean up this. We can see it for valid condition, how you can, sorry, yeah, how we can ensure that the current condition is valid one. So we can see this, in this is the valid condition. In this case, all the element in left side is lesser than all the element in right side. How we can ensure that? As we know that all the arrays are sorted format, so this L1 is always going to be lesser than or equal to R1, and similarly L2 is always going to be equal to R2. L2 is always going to lesser than or equal to R2, so we don't have to check this, but we can check that the L1 should be lesser than R2. This is the first condition. L1 is always should be lesser than equal to R2, and similarly R1 L2 is always lesser, should be always lesser than equal to R1. If this condition is satisfied, we can say that this is the valid one. We can check in nowhere this is true. So this is the valid condition, and whenever you find out that we encounter this valid condition, we have to do some work here. So this is the valid condition. How you can make sure that L1 is lesser than equal to R2 and L2 is lesser than equal to R1. If it is true, in that case we have to return our value. So there can be two cases, either length of the array is even or it can be odd. So in even case we have to return some value. So let's see. So we have found out the valid condition, and how we can find out those two middle element. Let's see. So here we can see that those two middle element is 5 and 6. So there are two elements L1 and L2 on left side, and two elements on right side R1 and R2. So whatever the maximum among L1 and L2 is going to be the one element, max of L1 and L2 is the one element, and the second element is going to be minimum among R1 and R2, minimum of R1 and R2. Okay, so these are two elements. So in that case we can return, if it is even, then we can sum these two and divide by 2 and return it. Okay, but what if the length of array is of odd size? In that case we are doing the maximum one at right side and minimum in left side, as we can't keep the equal number of element in both side. So either we have to keep 5 at sorry, max minimum is left side and maximum at right side. As we are keeping maximum at left side, we have to consider the maximum of L1 and L2. So let's go and write down. So in that case, return max of L1 L2 plus mean of L1 sorry R1 plus R1 R2 and divide by 2.00, okay, or 2.0. And for else case, in odd condition, we have to return max of L1 L2. If we are keeping maximum element at right side, that is 6 at right, 5 at left, in that case we have to return minimum of R1 R2, okay. So what are these two test cases? We have to either move forward or backward. Whenever we have to move forward, let's see. So we can see that in this case, in this condition, we are moving forward. We are shifting our L1 in right side, okay. How we can do that? We can do that by doing right equal to 1 second. First we have to verify that condition. So how we can check that this is not the valid one? So whenever we are encountering condition that any of this is violated, so we can say that this is not valid one. If the first condition is violated, that means L1 is greater than R2. So let's see which which condition is this. So we can see that, yeah, here L1 is greater than R2. So in this case, what we have to do? In this case, we have to shift backward. We have to go backward. Okay. So how we can do that? We can do that by using right equal to partition 1 minus 1. Okay. And the second condition is L2 should be lesser than equal to R1. If it is violated, that means L2 will be going to equal to greater than R1. As it is going to be handled in else case, we don't have to write this, but in this case, we have to shift our partitions in the leftward side. We can do this by using left equal to partition 1 plus 1. So if the first condition was L1 is greater than R2, yeah, L1 is greater than R2. So in this case, move right equal to partition 1 minus 1, and in this case, move left equal to partition 1 plus 1. So this is the code that we have to write down, and I think this is going to work. Let's see. Go to the compiler and we will be solving this. Let's zoom the screen a little bit. Yes. So first we have to find out the length, that is going to m going to equal to n equal to nums 1 dot length, and m is going to equal to nums 2 dot length. Okay. So as we are doing binary search, we'll make sure that we will always doing the binary search on the minimum size array. For that, what we are going to do, if n is greater than m, then in this case we will return this as find median sorted arrays, and we will replace nums1 with nums2 and nums1 with nums2 and nums2 with nums1. Okay. So this is done, and let's initialize the left equal to 0 and right is going to be equal to the extreme right position, that is going to equal to right equal to n. Yeah. Now as we have written down, I don't need to explain this. Left is going to equal to lesser than right. This is the condition that we always follow in binary case. First we have to find out the partition 1. Partition 1 is going to equal to left plus right divided by 2. and partition 2 is going to equal to, we have discussed this earlier, m plus n plus 1 divided by 2 minus partition 1. Okay, so we have find out our partition 1, partition 2. Now we have to find out our L1, L2. So L1, first we have to check out is partition 1 is equal to, sorry, is partition is equal to 0. In this case, what we have to do, we have to do the minus infinity. How you can do that? By using integer dot mean value. And nums1 partition 1 minus 1. Let's copy this. Yeah, for L2 it is going to be similar, just return partition 1 with partition 2 and nums2 with nums1, and we are good to go. For R1, sorry, R1 we have to check which partition 1 is equal to n, then in this case we have to replace with max value. Yeah, and nums1 is fine, and in this case it is going to equal to partition 1, partition 2 for R2, and this is the nums2. Everything is okay. We have to check partition 2 is equal to m. In this case it is R2. Yeah, so we have find out our L1, L2, R1, R2. Then there is some condition, if case, else if condition, then else condition. Yeah, so which one will be valid? So how you can find out that this is the valid condition? When L1 is going to lesser than equal to R2, and at the same time L2 is going to lesser than equal to R1. If it is of length even size m plus n percent 2 equal to 0, then we have to return math dot max L1 how you plus math dot mean R1 and R2. Okay, and divide by 2.0 as we have to return the double value. In else case, if it is of odd size, we have to return math dot max L1 and L2. This is the condition when we have to move backward on the right side. So if L L1 is greater than R2, then in this case we will be moving the right into partition 1 minus 1, and in else case shift left equal to partition 1 plus 1. Yeah, for satisfying our return value we will return any integer that is minus 1. Let's run this. So yeah, it is nums1 and nums2. Partition 1, it was partition 1 minus 1. Okay, yeah, first test case has been accepted. Let's check the second test case also. Okay, both the given test cases has been accepted. Now submit this. Yeah, our solution has been accepted and it is faster than 100%. So this is the optimized approach that we can come up with. Okay, so I think this video has must taught you something, and in this case we what you can do is please like the video, subscribe the channel, and if possible please share the video. Thank you.